Welcome to Ask and Learn.
In this problem, we have a cylinder which initially contains air at a specified state. Heat is transferred to the air and the air expands isothermally. The boundary work done is to be determined. So we assume the cylinder here is stationary and thus kinetic and potential energy changes are zero. We assume that the air is an ideal gas with constant specific heats, and that the compression or expansion process is quasi-equilibrium. So we take the contents of the cylinder as the system, and since the system is closed, no mass enters or leaves, we can use the energy balance equation. For the closed system, the energy in minus the energy out is equal to the change in energy of the system delta E. Now, the energy in is due to heat. So the heat transfer Q in minus the boundary work out of the system is responsible for the change in internal energy delta U. So we can write delta U as M into U2 minus U1. And we can also write this as M CV, the constant volume specific heat, into T2 minus T1, the change in temperature. But this is an isothermal process, so the temperature is constant. So T2 and T1 are equal, and hence this right-hand side becomes zero. Now, this implies that when T2 is equal to T1, like the situation we have above, U2 is equal to U1. So the internal energy of both states are the same. So what this means is that from the energy balance equation, that the boundary work out of the system is equal to the heat transfer into the system, and we are given that to be 40 BTU.